You and me, we're humans. We drink, we sleep, but most importantly, we eat. To our ancient ancestors, eating was simply a means of survival, and nowadays it tends to be a source of enjoyment. But robots, well, they can't enjoy it like we do. Most robots don't have mouths or stomachs or really any sense of taste, but you and me, we're gonna change that. Our starting point is going to be this robotic head, and by starting point, I mean I'm stealing its eye mechanism because I might have destroyed the rest of it a month ago. To turn these eyes into a sentient robot that can eat anything, we're going to focus on three main aspects, the first of which, of course, being a mouth. Our own mouths work on a complex mechanisms of muscles and fibers, but a mouth's movement is actually pretty linear. It crushes things. The mouth is made up of two components, each painstakingly designed and assembled, and the base material is PLA, which is not food safe for humans, i.e. don't make your utensils out of it, you might cease to exist. But robots, on the other hand, well, they don't really care about that. On each side of the mouth, we've got a motor, each with their own regulated power sources, and when we go to spin them, the mouth moves. As far as motors go, these ones are pretty slow, but as a result, they have a really high torque, which is going to be important a bit later. Since we're omnivores, our teeth are shaped like this, good for crushing and slight piercing, but not great for getting through thick animal hides like wolves or tigers. I've chosen to stick to that more omnivore/herbivore design for our teeth because it's going to be more flexible for eating all sorts of things, like even rocks. What did he say? Don't worry, buddy. I'm not gonna make you eat rocks. Come on here. In our robot's mouth, we've got parts that are better for crushing. These are our molars and premolars, and parts better for slicing, which are our incisors. In a human, this happens for quite a lot of reasons, but in our robot, the one we're gonna leverage is position. These motors have a stall torque of 2 kilograms per centimeter, which means they can provide 2 kilograms of force 1 centimeter away from the center of the rotation shaft, but that is not what we are getting. Instead, we need to consider a lever system with 3 primary components: our pivot point, our line of action of the force, and the perpendicular distance of the lever. We can then use this lever equation, throwing all of these components together, cancelling our distance units, which gives us a crushing force of 0.45 kilograms for our molars and 0.2 kilograms for our incisors. And we have to multiply all of those by 2 because we have 2 motors. Our upper jaw section connects to our eyes, which are just 2 motors at right angles to one another. The really cool thing about these eyes is I painted them. I painted since I was... Did you say something? Anyways, I haven't painted since I was 4 years old in kindergarten, and I'm pretty proud of it. It looks pretty good, not great, just good. The bottom motors control the actual eye side-to-side movement, whereas the right motors control your eyelid movement. When paired with this nose section, it kind of gives the impression that the eyes are blinking, but honestly, I'm probably just going to keep this off for most of the video because I want this thing to haunt your nightmares. Believe it or not, these motors are not controlled by magic. It's actually this PCB way, PCB. It's very basic. I've chucked 3 motor driver chips on it, and through the whole board, we've got some thick power and ground rails going through for delivering current to these motors. These connections are absolutely tiny though, so I did get PCB way to manufacture and assemble the board, and the quality of the board is great. If you're considering making PCBs, 3D printing, or even CNC milling for your own monstrosities, then I recommend them. Circuitry aside, the PCB still needs some commands, and these come from our brain. Our brain should slot nicely into the largest part of the print, what I'm calling the chromium, but I failed to design for the height of these wires, or the height of my screwdriver, so our PCB and brain doesn't exactly fit or secure, so this 12-hour print is now absolutely useless. But I've got one idea to fix this without needing a reprint. Don't hate the player, hate the game, sucker! Success! I cannot believe how conveniently that broke for me.
And presto, this is still completely asked to do, but at least it's possible now. So now we can put our brains into our chromium, and once I get these screwed in, we'll integrate it into our overall head.
At this point, the head, especially the front section, is getting pretty heavy, and that means when we want to move the jaw downwards, nothing happens. That's because the motors can't overcome that force due to gravity of the weight of the big boy head. And this makes sense. Trying to balance the weight of your body with just your jaw muscles, robot or human, is probably not very possible, so I've developed this highly sophisticated system that I'm calling the balancer because it balances everything. To implement the balancer, I've had to redesign this upper jaw section, basically just implementing some screw holes, and while I was at it, got rid of this absolutely abysmal attempt at creating cheekbones. Since the upper jaw is the center point of all the head's components, I've had to completely disassemble and reassemble the head to incorporate the new design. Goodbye that hour of my life.
Absolutely useless!
But now, wow, look how pretty he is, and not absolutely terrifying. I'm running a Python script on this board which is doing our sentience, but rather than boring old me explaining that to you, I think it's best we ask Mr. Chomp, and Mr. Chomp does sound like a woman. We're calling that a feature.
What mode would you like?
Voice. How does your brain work, bro?
My brain is a complex system of electrical signals and algorithms, processing information rapidly and efficiently. I am sentient.
I just wanted to demonstrate the mouth moving. I obviously actually knew that. And the only thing that didn't move was the mouth. But a few minutes ago, the mouth was moving. Truth be told, the mouth never works twice. My theory is that these motors are such high torque that the moment any resistance is met, i.e. hitting either the maximum or minimum extension or something getting in the way, like a banana or something, the motors, instead of stalling and subsequently holding their position, instead they cause enough internal friction in the joint structure to turn this into this, effectively meaning the motors are just free spinning and hence the jaw doesn't rotate with those motors. This is mainly a mechanical issue, so I'm gonna make some changes, but firstly I want to make a change to the electronics, mainly these goofy wires. Luckily, I've assembled two PCBs, so this one is gonna be our hard soldered version, and I've failed to capture any of that soldering process in frame. I then removed the brain and PCB from the chromium, which does get its own mention because it took me an hour, and I also didn't capture that in frame. And then finally, I was able to reorder the wires on the PCB to make more logical sense, replacing this for this, this for this, and this for this. And this one I actually did get in frame, it's just boring. Mechanically, I've switched up our joint material from PLA to TPU, which is a more flexible plastic, so hopefully less susceptible to wear and tear. I then super glued those joints onto our lower jaw socket, and it worked pretty damn well. Psych! It doesn't work at all. This is it so-called moving.
What is that? What is that?
Since that was such a failure, I've decided to redesign the lower jaw, taking what were previously the hinge joints, cutting them off the top, and creating a lock-on system that screws in nicely, so the torsion experienced by the joint is more distributed. And with that... Yes! Let's go, baby! With sections 1 and 2 completed, we've got one final section before Mr. Chomp is ready to chomp down on some food. Hot, stinking good looks. The general structure of the head is pretty set in stone with all the 3D printed parts, but I deliberately made the whole structure white so I can paint over it. I'm gonna take some inspiration from movies here. I'm between either a Transformer or Fender from the Robot movie, because he kind of looks like it. But I can't decide, so... Hey Mr. Chomp, would you rather look like a Transformer or Fender?
I'd rather look like Optimus Prime. Transformer vibes all the way.
Well, that is hard to paint, but I'm gonna try. 2 hours later. No, really, look at the size of my paintbrush. I've learned 2 things about painting here. Firstly, you get a lot of paint on your hands, and secondly, I suck at painting. Le restaurant, le robot geese. Firstly, we have a Caribbean delight, fermented with a light seasoning of volcanic ash. Le côte banana. I'm not going to lie, I wish I had some stronger motors. These motors barely even caused an incision into the banana. How did you enjoy le banana, sir? What is going on with your eye?
Delicious delicacies. Lebanon never disappoints. Beirut is a must visit.
What? And now, for your final meal, sir. Rocks. Eat it! Eat it! Thanks for watching. Subscribe. Thanks to members. Wait, I don't have any members. Cut the video!